The majority of enterprise data exists in heterogeneous formats such as HTML, PDF, PNG, and PowerPoint. However, large language models do best when trained with clean, curated data. This presents a major data cleaning challenge. Unstructured is focused on extracting and transforming complex data to prepare it for vector databases and LLM frameworks. Crag Wolfe is head of engineering and Matt Robinson is head of product at Unstructured. They join the podcast to talk about data cleaning and the LLM age. This episode of Software Engineering Daily is hosted by Sean Falconer. Check the show notes for more information on Sean's work and where to find him.
Craig and Matt, welcome to the show.
Hi, Sean. Thanks. Great to be here.
Hi, Sean. Thanks for having us.
Yeah, thanks so much for being here. I like the dynamics of talking to a duo, anything they kind of like get a little bit different flavors in terms of the conversation that can go on and so forth. But so thanks for being here. Why don't we start off with some introductions for the audience? Who are you? What do you do? Why don't you start, Craig?
Sure, yeah. So I'm Craig, head of engineering at Unstructured. Have been in the industry a while. Previously had worked together with Matt and the founder, Brian, at Primer.ai and led couple of engineering teams there, but that's me in a nutshell.
All right. And Matt, who are you and what do you do?
And hi, I'm Matt Robinson. I'm head of product at Unstructured. Depending on the day, I sort of do work across product and engineering. I come from an ML, NLP type background. And when we first started, I did a lot of work on our open source package and then do all sorts of various and sundry things now.
Yeah, well, such is the nature of a startup. We all wear many, many hats, I think. I used to say when I was a founder that I did everything from write most of the code to sell the product to take out the garbage on a daily basis, essentially. So we're talking, unstructured data. I'm excited to talk about this and talking also about the company, your company Unstructured. I feel like I've had a lot of conversations kind of on this topic recently, both in my professional life and also in my sort of podcasting life. And I think obviously there's been this huge growth around generative AI and LLMs over the last year and a half, which I think is why there's been sort of some heightened level of conversation and focus on this. But the reality is most of the world's data is unstructured, something like 80 to 90%. And we really haven't had technology to sort of unlock it. We have data lakes and things like that, but they take a significant amount of maintenance and manual work to kind of actually create the metadata around that unstructured data and make it something that you can actually leverage. So most companies are kind of sitting on a mountain of this stuff that's locked away, and it could be an S3 bucket, it could be their email. Essentially they have tons and tons of this information. So how do we get the data in a form that's actually useful without a bunch of engineering and manual work? How do we get beyond sort of all this essentially manual work that's involved with actually allowing us to query it, use it for analytics, use it for machine learning, and so on?
Yeah, no, I'll jump in there first. And I'd say this data has been around for a couple of decades now, I guess, right? And that there's emails, there's Office documents, whether they're Microsoft Office or Google type documents or other, there's video recordings, and they've all kind of lived separately from what would refer to as structured data, like databases with very strict schemas and that sort of power business intelligence, and as a totally separate universe from the knowledge that may actually exist in the company, which really exists more on what we call the unstructured side of the house. And so, I just wanted to sort of, double click onto what you're saying here, and that it's it is so crucial now to be able to unlock the value inside of all of that unstructured data. And the state of the art now with LLMs and multimodal LLMs is you present them with large amounts of text or actual images and documents, and you're able to ask them, questions about it for whatever knowledge you might be interested in. So I guess maybe jumping ahead a little bit here, but a key thing that in order to get there is, you can't throw all your documents at an LLM at once. So there's a key thing, which is retrieval, finding the relevant documents to narrow in on answers. And so how do you go from mountains of unstructured data to just be able to support retrieval for relevant types of documents, right? And that's exactly what Unstructured, the library and the company is all about, and happy to go further there. But the high level, absolutely.
Yeah, I mean, I think you called out an important thing there, which is like historically, we've kind of like treated these two types of data as like completely separate things. And we've had a good sort of like reasonable way of managing structured data, things that we could put in rows and columns, or even semi-structured data like JSON or CSV file or something like that. And we've been able to kind of take action on it as either engineers or product people, as a business. But then we have this like other stuff that is like lives over in the soup, and we don't really know how to kind of like do stuff with it, or you have to do stuff on a very like point by point bespoke process. And I think like if you ask like a random person who's not in technology about what they think a database does, I think they probably think about it as, oh, well, that's like a place where I could go and ask a question and I'll get an answer. But that's not the reality of a database. It's much more rigid than that. But now I think we're starting to kind of inch towards something like that being the reality, where we can ask a question and we get some sort of answer from being able to appropriately retrieve the data and combine that with things like LLMs. Matt, did you have something to add there?
Yeah, and you brought up a really good point about, like the traditional structured databases. We have a way to deal with those. And actually, like a lot of what we do is abstract away a lot of that ad hoc work that you used to do and take all of that unstructured data and put some structure to it so that it makes it easy to load into something like a database, whether it's a vector database or some other kind of database. And really, at the end of the day, a lot of what we're doing is we're abstracting that away and then making it so that you don't have to care what the source document was. Downstream, you can process it all in the same way. And so I'll talk about a couple examples. So first, like think about if you have an HTML file versus a Word document. Well, there's structure to both of those documents, but they're both different languages, different schemas. Like one is HTML, while the other is a pile of different XML documents. But to get that into a format that you can then deal with downstream in the same way, you have to go through and normalize all of those elements. So, like there could be an H1 heading in the HTML file. There could be a section header in the Word document. And you want to not care about whether it came from one or the other. And so normalizing those elements is a key part of what we do. Once they're normalized, it doesn't matter whether it came from the Word document or the HTML file. You can just treat it the same. And then same goes for stuff like PDFs. We apply models to, and in those other cases, we're using cues like XML tags and HTML tags and that sort of thing to figure out structure. Same deal on PDFs and images. We're just using visual cues, but end of the day, that all gets normalized to the same schema. And so once it's in that schema, you can chunk it, you can load it, you can do all sorts of different stuff. And it really doesn't matter what the source document is. And that's really a lot of where the power of what we're doing comes from.
What is the output of this process? Like, what is that normalized view of the data once you've essentially pre-processed it?
So it's really a couple of things. And so there's really three core things that we're doing. One, we're pulling out the raw text content from the document. Two, we're structuring the document. And so what we're basically trying to come up with in a natural reading order, hey, like here's the heading, here's some narrative text, here's some list elements. So structuring the documents into what we call document elements. And then third is pulling out metadata from the documents. And that really falls into two categories. One is information that we pull out of the document itself. So stuff like page number, last modified date, that sort of thing. And then some that we actually infer from the structure of the document itself. So maybe like this piece of narrative text is a child element of this heading, for example. So we pull all of those elements out. And in the end, for us, it's a JSON object that's just a list of objects with all of these elements in there. And then really what that allows us to do is then go easily chunk for LLM applications. And then the metadata allows for things like filtering for hybrid search and some of these more complex LLM operations that some of the more recent LLM apps are doing.
Maybe we can back up a little bit and go through walk me through like a use case, like from essentially where I'm starting as someone using Unstructured to essentially get to the place where I'm generating this output.
Sure. I mean, like a really simple use case would be, I have a Google Drive. There's a shared Google Drive for my organization, and I want to be able to query the information in that Google Drive. And so processing all those documents and putting them through the transform step that Matt was referring to, where we get the same structured JSON for each document, regardless of the type it is. And that could be a native Google Doc as well. And from there, the rest of the pipeline basically looks the same. Chunk it. There's various chunking strategies that you could use, and you could experiment with different sizes of the length of the chunks. And, again, like the vector database that we're writing to is probably going to be a vector database to support semantic search, like is also configurable. So, but, end of the day, it's a fairly straightforward ingestion process. And that data is now ready to be queryable for like the simple sort of, chat GPT use case of I just want to like chat my documents and ask questions about them.
So in the scenario that we're talking about where we're processing files from Drive, what is like the performance like? Am I doing that in batch? When I add new files, is there like a real-time update? Like how does some of that stuff work?
So for sure, initially it'd probably be a batch to load your 10,000, 100,000 million docs. And that's something the platform that we're writing to basically allow users to specify the Google Drive location and all the parameters they need in the pipeline. And so, the first time around is probably going to take a little bit longer, given the number of documents. But then there's basically an option to keep the vector database warm so that we keep looking for new documents. And so that vector database is always kept up, up to date with a little bit of latency, perhaps, the source documents themselves.
And then what's happening kind of like behind the scenes in order to process these docs and then mapping that essentially to this normalized, essentially you're preprocessing the files to normalize them into this output. And then from there, you're applying chunking strategies to build potentially like an embedding model or something like that.
Yeah, so we ourselves don't build embedding models. So we're typically preparing data for NLP type use cases. And so somebody might prepare a bunch of domain specific documents using our file transformation technology, for example, for the purpose of training an embedding model. We do, in some cases, interact with those models, typically on the way to a vector database, and we have integrations for that. And so, like, if you wanted to load your documents, for example, from SharePoint into a Weaviate vector database, we would potentially call an OpenAI embedding model or something along those lines ahead of loading those documents. And but our use case is on the pre-processing side for the most part. And you asked a little bit about like what's going on under the hood when we do that. There's really two categories of methods that we use for data preprocessing. One are rules-based parsers, and then we also have model-based parsers. For the rules-based parsers, that's going to be a lot of, very honestly like tedious logic for taking those source documents, whether it's PowerPoint or Word doc or HTML, and then mapping it to that common schema. Fortunately, like those run really fast. So it's like, like well under a second per page. Like it's usually like kind of like 0.1 seconds per page and faster for that. The tougher ones are always the PDFs and the images, which are model-based workloads. Really kind of two ways we do that. One is with object detection models. So same sort of model that you would use to be like, hey, like identify this car or something like that in an image. We're doing the same thing. We're just identifying page elements based on visual cues instead of identifying the car in that case. We also have models that we're experimenting with on that end called vision transformers that act sort of similar to a text transformer, except instead of text in, text out, it's image in and then text out, with the text in this case being a structured JSON. So that the model-based workloads run a little bit slower because they're heavier duty. They run about like 3 to 5 per second per page for us on CPUs.
Mm-hmm. Okay, so if we're thinking about like a RAG pipeline where essentially I want to create a bunch of embeddings, store them in a vector database, where Unstructured sits in that process is really at the beginning of that, where it's essentially the head of the ingestion pipeline to clean up all this data to make it ready for chunking and embedding.
Exactly.
Right?
And we think of ourselves as the connection between all of your messy source documents where all of your organizational knowledge lives and the LLM. So like, you're exactly right. We sit at the top end of the funnel for a RAG application.
Yeah, and like data quality is such an important aspect of building anything in machine learning and AI. So like, what is some of the sort of performance gains that you're seeing people get by essentially being able to properly pre-process the documents and generate sort of this normalized view of it versus maybe something else that they might be stuck doing on their own?
I mean, I'd say it's, as we've mentioned, like there's really broad range of document types to support, not to mention different sources where they may not be, where the document type itself may be native to the source, for instance, a SharePoint document. So the critical thing for a lot of users is really that we're segmenting that data correctly. So the schema that Matt was talking about before, that we are able to, number one, cleanly identify the text, if there's text in the documents, if they're Office type documents, to natural reading order. So for multi-column docs, if you're just running raw OCR or using, other transformation pipelines, multi-column documents will often trip up the outputs there. And then additionally, another big sort of subcategory where the accuracy matters a lot is in tables as well. So if there's an embedded table within a PDF or Word doc and HTML, having an accurate representation of that in the JSON output itself. And so we're always tracking our scores versus some, I guess maybe undisclosed competitors at this point, but feeling that we have the edge across all document types and encourage users to verify that themselves against our API.
Yeah, what is the output when you do something like you're processing a table? Like, what are you actually generating on the other end of that table?
So yeah, great question. I think in the JSON schema itself, it's a ordered list of elements from the document in natural reading order. So if there's a table, we have a element type called table. For the actual cell structure and the content within those cells, there's an additional metadata field called text as HTML. And so we happen to choose HTML as the representation for tables because it covers cells and rows and column spans and row spans. It could be something else, but that allows end users to then, and the end user could be an LLM in a RAG application as well, query that table. So that's basically what's going on in terms of the JSON transformation.
And what about in terms of like processing a PDF where the actual like pages in the PDF are images of like text? What's going on there in order to convert that into, I'm assuming, a text representation?
I'm really glad you asked that. Because PDFs there's such a variety of types or subtypes maybe of PDFs where they're all embedded text or they're all scanned pages or they're a mixture of embedded text and images per page. So in the case of the scanned page, we treat it as an image basically, and so we pass it through an object detection layer where we're able to identify tables, headings or titles, paragraphs, or narrative text within the page itself and pass them through the rest of the pipeline as we would, any other content that's coming through. And so those outputs so if there's a table within that image, we'll recognize it as a table, we'll take the OCR steps that are needed, and we'll basically extract out the cell at the cell level for that table of content.
You mentioned earlier that you're starting an experiment with being able to convert actual images as well into like a textual representation. So is the output of the text essentially like a human description of the image?
Yeah, so that would be the idea there. And the idea is that you have documents, there could be an image in the document or maybe like a figure or something like that with a caption. And you want to be able to retrieve that as part of your similarity search. There's really kind of two methods we're experimenting with for this right now. So one would be you get your image or your figure or something along those lines, and then kick that out to a computer vision model, get back a text description of that. And now it's like, hey, like this is a graph and it's going up and to the right and it describes GDP or something along those lines. Or, hey, like this is a picture of a skier skiing down a mountain. And then now with that information in the text key in our JSON output, You can load that into the database, essentially treat it as text when you're doing your similarity search, and then if you want to kind of pull back images along with text in your LLM application. The other sort of like easier way that we're doing that is just OCRing the image. So like if you have like a picture of a stop sign or something like that, you wanted to OCR that and get stop out there. That's something that we do for those as well. More future facing, there also are like kind of like multimodal retriever embedding type models that we might experiment with, but we're very practical. We kind of do the simple stuff first that gets our you kind of like users unlocked and going, and then kind of expand out from there as we get further along.
Yeah, absolutely. I mean, I think that I would think like the biggest sort of hurt for businesses right now is just taking their textual data that's locked away in doc files and PDFs and all these different formats and stuff like that, and being able to either bring that into an LLM for whatever sort of application that they're building, or just build a better retrieval system so that they have kind of like a single source of truth for getting into helping people find the answers to various like internal information and so forth. In terms of the like data processing steps for doing something to be like RAG ready, you have like cleaning, there's chunking, summarizing, embeddings. Like, is it primarily Unstructured handling the cleaning part of that, or is there some level of support for like the chunking? I know that you're not necessarily interested in you're not building your own AI models for embedding. You're going to leverage something else, but sort of like where's that begin and end, I guess, in the process?
Yeah, so there's actually a lot we do on the way to the vector database that helps with retrieval once it's there. And like chunking is actually a big one. So Craig brought up earlier, we're pulling out all of these document elements, and we're doing our best to make those like really, really accurate. And end of the day, we're not just doing that for fun. There's all sorts of stuff that we can do that, although it is very fun. There's all sorts of stuff that we can do with that information to help prepare data for the LLM app. One of those is chunking. And so you can think of, we've got this structured information in reading order about the document. And when you think about chunking, traditionally, how you do that is you take a great big long document and then you just chop it up. So I'm going to chop every X tokens or X characters. By breaking down the document into its elements first, we can actually chunk in a different way. Instead of chopping up the document, you can actually build chunks up from the atomic document elements. And so what that means is we can, say, identify a title or a subheading or a list with bullets underneath and be like, hey, like this stuff belongs to the same section, and then group that together into the same chunk because we have structural information about a document. So what that means on the other end is when you're doing the retrieval for the LLM application, what you're able to do is get back content that belongs to the same section. So it's going to be more coherent, and you're going to get more relevant context to inject into the prompt. And ultimately, you're going to get a better response on the other side. One of the other things that we enable too by doing this pre-processing. And so like really end of the day, the most expensive part is going from the raw document to the standardized JSON schema, especially in the cases of PDFs and images, because those are model-based workloads. Once you have it in that schema, we chunk on top of that schema. And so that's really inexpensive. You can experiment with 10, 20, 30 different chunking techniques and with different parameters really, really quickly. And we're finding that that's really important because with this being a very new field, there's not necessarily a playbook out there yet. And people like really do need the ability to rapidly experiment. And so like we're not just doing the data preprocessing, it also enables rapid experimentation with a lot of the stuff that impacts LLM results.
What are some of the common chunking strategies that people use?
Two of the common ones that we're seeing right now from our standpoint are like one based on structural and hierarchical information. And so like that's one that we've been working heavily with. Another really interesting one that we've seen used heavily and that we support is similarity based chunking. And so what that'll look like is, you start constructing a chunk. In our case, we're adding elements to the chunk as we go along. And you'll essentially set a threshold. And if the content switches dramatically enough between document elements, you say, hey, this content is not similar enough anymore. We're going to break off into a new chunk. And so we've seen a lot of success with that. Actually, we have an archive paper floating around out there that our ML research team put together. It's a really, really great and interesting paper that outlines some of the performance differences between various chunking strategies too.
Okay. And then right now, I think there's a lot of sort of hype around like long context windows. And it feels like that's kind of like the new hotness for 2024 in the world of LLMs. And people talk, is RAG dead? Because now you have these like long context windows and so forth. But like, does that have any impact? Like if we have essentially, let's say we have unlimited context window or really, really big context windows, does that impact at all the strategies that you might use from a chunking perspective?
I mean, it probably would to some extent. And I think where it gets interesting for RAG is in the, of course, fundamentals of RAG, retrieve K documents and present them to an LLM. So the more documents that you're able to present to the LLM, given the long context window, maybe the less you have to really fret about getting re-ranking right after retrieval. So, I mean, I think the longer context windows, if anything, are just going to supercharge RAG applications in the future, because in some sense, there'll be less sort of, even less like old-fashioned data engineering and trial and error to go through if you can lean a bit more on the LLM and say, look, here's the 500 documents, just give me an answer. But I also, like, at the same time, don't think the infinite context length windows as a thing don't seem to, I would say, are not like something that's going to fundamentally disrupt RAG in terms of like the next, say, 3 years. You know, if you have tens of millions of documents to work with, you know, you're not going to be able to throw them all to single LLM. We can talk about fine-tuning an LLM, which is a separate discussion, of course, but versus like one shot, here's all the data, give me an answer.
Yeah. I mean, I would think even from like a practical computer science perspective, like how realistic would it be, even if you had an infinite context window, to be able to grab all your documents and shove them into the I mean, I guess it depends on like what the use case is. Maybe in an agent where you don't need real-time response, it's different. But if you're actually doing something that's more of like a co-pilot chatbot experience, like it's just, you're not going to be able to put that much information across the wire to your LLM and get a response back in a reasonable amount of time.
Yeah, and like you would have to do that, by the way, like every time you ran a prompt too, and like that gets obviously prohibitively expensive pretty fast. So I mean, you were talking about like, hey, like here's my Fortune 500 company, and I've got, you know, like 500,000 PowerPoint slides or something like that. Like even beyond some of the other just kind of like performance considerations, you know, like there's still kind of, you know, kind of like lost in the middle type issues with long context windows and that sort of thing. But even if you solve those, like loading all of your organization's knowledge base into a prompt every time you want to ask a question just gets like really infeasible really fast.
Yeah, it seems like a very hacky solution at the very least, if that was even possible. In terms of like, you know, if we weren't using something like unstructured and we need to build something like a RAG model, like what are the current pieces of like technology people are sort of cobbling together in order to solve that problem to essentially get their data RAG ready?
It's really a mix of stuff. And really, like from our perspective, what we do really well is we do like all of the different document types, and we do all of this end to end. If you're not using a tool like Unstructured, you're like typically cobbling together like a combination of cloud document processing solutions, like an AWS Textract or something along those lines. But that's not going to do every document type. So like, hey, like I've got to pull out like Python docx library. Maybe I've got to pull out like LXML for like XML files, couple all of that stuff together. At that point, like you're also stuck coming up with your own schema for normalizing all of that sort of stuff. And we also handle like the loading into the vector database and the connections to the upstream, like data sources and then that sort of thing. So like if you wanted to do this by hand, the tools are out there. It's just a pain in the neck and nobody wants to spend all of their time doing that. At the end of the day, people are a lot more interested in working on the LLM app, which if you have like domain expertise is where your time's going to be better spent anyway. And so, yeah, like we do a lot of that for you. And like really like the origin of this company is Crag mentioned that we had been working at an NLP company before this. And like really what we would notice is every time we would go on a client engagement, they'd be really excited to do the NLP. And we'd be like, hey, like, we're excited too. Like, where are your documents? It'd be like a whole huge mess. And we had just like written these one-off solutions to this like very tediously so many times that, it just seems like a really great idea to put together tooling to just tie it all together.
Yeah, it makes a ton of sense. The timing is really good too, given the state of the world. So there's different sort of flavors of unstructured in terms of how people use this. There's essentially like a SaaS-based API that looks like you have sort of like a enterprise level version of the product. Can you talk a little bit about like what are the different sort of usage models?
Yeah, so to talk about the usage models, I guess we think of there really being three use cases or three tiers of users. So, the open source community, of course, is active and can be great for proof of concepts and, for whether students or data scientists or data engineers at an enterprise for like Fortune 500 company. However, like once you sort of kick the tires, you validate things are working well, like to get a little bit better performance. So it's like, okay, this seems to be working, but this table was not quite what I'd expect, or I'm missing, like this output just doesn't feel quite right. For the API itself, we do have proprietary models that basically have an edge in performance over the open source offering. And so for data engineers that are really comfortable writing their own pipelines or already have existing pipelines and they're doing RAG entirely themselves, the API is a great way to go. We believe most users are going to not want to have to manage these data pipelines themselves to get their data RAG ready. And so that's the platform product that's in private beta that's basically ingest ETL for LLMs. Has an admin UI. You basically configure your sources, the different parameters we've been talking about regarding chunking and embedding. You set up any number of workflows that you want to. It could be across different data sources, going to different locations, going to the same location. And then that's basically all taken care of for you. And you can just worry about building the end user application. This data is all ready for retrieval.
So in that scenario, I basically have my source data, and then am I pointing it to like a vector database that I'm in control of, and essentially it's just input, output, and everything works like magic?
So the source database would probably be more something like a Google Drive, a S3 bucket, a SharePoint, could be like a traditional database as well. And the outputs or the destinations that you also configure would be something more like, one of the standard sort of vector DBs, like a Weaviate, a Mongo, Chroma, Pinecone. Or if you just want to store the JSON outputs, that's also like a legitimate use case. Could just be a blob storage location, like an S3 bucket.
So I guess in sort of conventional structured data world, this would be a little bit similar to like a Fivetran or something like that, where you're connecting it to a bunch of structured data sources in order to dump into like your warehouse.
Yeah, that's exactly right. So we're laser focused on the unstructured use case. And so there's fundamentally some differences in the abstraction layers going from, say, structured data to structured data. And so we're just very much focused on getting that right for our users, but also, not exploding the use case or exploding the complexity for users that need to operate this as well.
Mm-hmm. Yeah, makes sense. In terms of when it comes to document like processing, we've talked a little bit about some of the challenges with like tables, images. Like, what are some of the other things that make processing and cleaning this type of data particularly difficult?
There's like all sorts of stuff that we could like run down the list on, but like everything from encodings, we've got like people like processing documents in all sorts of different languages. Like, hey, I tried to process it in, like with this character set and it came through weird, like that sort of thing. One of the ones in Word documents specifically, and as far as I know, this is like only a Word document thing, is you can actually make tables that like aren't tables, like you can make it like a T-shaped and that sort of thing. And we just like recently worked through an issue to where like if you would just like slightly wiggle the cell length with your mouse, it would like mess things up and it was no longer like an actual table. And so it would like break things in our Word document pipeline. We probably have like 1,000 things like that are just like little things that you would never ever think about if you weren't just pre-processing documents every day. Of course, you have like the more, I guess, like interesting modeling problem. How do you extract and transform tables, like how do you do forms well and that sort of thing. But like it really is, the file transformation part like really is in itself like a full-time job. There's like so many nuances to all these different document types. And when you're doing all of that, you just run into like all sorts of stuff all the time.
Is there a big difference when it comes to performance around like accuracy of being able to pull out some of this information based on language, like English versus French versus Chinese or something like that?
I'd say we're extractive. And so like we're not as sensitive to language differences, for example, as a downstream NLP model would be. I would say probably the biggest challenge for us with non-English languages, and it is really languages where there would be formatting differences. So if it's like an up to down language or a right to left language instead of left to right, or if it's just a document set from somewhere else where just like typically the formats of a document will be set up differently. There's like formatting type differences tend to trip us up more than language differences do. Language differences like could potentially trip us up like a little bit on some of the element detection type stuff too, but it's really like format more than language that we spend more time dealing with.
How's like testing work with this? Like, how do you know when you make changes that you're actually moving the product in a better direction?
Yeah, that's a great question. There's multiple layers and where we're ensuring that we are moving in the right direction. So it begins with the open source. And just to talk more about what Matt was saying, we also get contributions for bug fixes in the open source as well that carry through into the product. And so, it begins with the open source. We have, of course, we have CI that runs hundreds of real documents through the library, to ensure one, it's not breaking, but we also have a low bar, or I should say not low bar, like a small number of documents to ensure that like our accuracy scores are still not regressing, and that can be reflecting reading order or that we're capturing all the words in the document. Internally for the product, we're doing a bit more. So we're tracking against a data set that we think is more enterprisey in terms of has large number of PDFs represented, but not only PDFs, has a good number of tables. And so we're basically our CI will break across those hundreds of documents if our score regresses. So that's another thing we're doing. And then finally checking, before cutting a release, doing more than checking those hundreds, but thousands of documents, because we support 25 different document types out of the box. And it's a lot of surface area. And like we're talking about PDFs before, there's kind of like the subtypes of PDFs to think about and different languages, right, that we've also touched on. And so we do have extra tooling there as well to, ensure the quality of our releases.
You said you support 25 different document types. Is slides one of those?
Yeah, PowerPoints. So PowerPoints, whether they're the old, really old fashions like 2007 or the more modern PPTX, yeah.
Mm-hmm. Okay.
Or Google Slides as well. If you're processing through Google Drive, the Google Slides basically get converted to the PowerPoint format and then get passed through the pipeline.
Mm-hmm. Okay. And then with these documents that you're using as part of the testing in the CI, essentially, do you know what the ideal result is? Because some person or group of people have essentially done the work to hand normalize those, and then you're comparing it against the essentially human generated ones.
Yeah, that's right. So we have a ground truth document set that we had human labeled. And so that's what we're making our comparisons against as we're running through CI.
How long does that take, like, to make, going through those hundreds of documents as part of the CI? Is that something that slows down the build process in any significant way?
I would say not in a very significant way. I mean, CI can always be a little bit faster, but there's nothing stopping from people working concurrently and then automatically merging their PRs. So we're using GitHub internally, once they pass the tests. And there's no human check on, oh, you've regressed on the scores. Like that would fail CI, right? So no one has to babysit to make sure that that's going to be merged.
And in the actual production system, like where can scale start to become like an issue or challenge? Like where do you have to think about essentially your scalability issues?
I mean, there's two levels. There's the API. So we have two products, right? So we have the API and the platform. And so both, I think for the API is a much simpler thing. It's just a single endpoint. And so in terms of supporting that, it's mainly supporting autoscaling and also being able to quickly stand up additional clusters if needed to support as volume increases. So we feel really confident of being able to handle any scaling challenges on the API side. But, platform also has the similar issue of processing 1 million documents and how those progress through the pipeline. But we have auto scaling steps along the way. It's all taking place in Kubernetes with key to autoscalers. So, you can think of the linear progression as we've described it. It can be a bit more complicated than that, but, having autoscaler trees ready to go as there's documents available to process.
And then are you using some sort of like queuing system essentially when these requests come in? I'm assuming like in a batch type of request, they give you an endpoint. You're going to hold on to that and then go through some process. And how does sort of like failover work if you can't reach the documents?
So to your point, like a document can fail at any state. Maybe like the embedding endpoint just disappears, stops working for whatever reason. And so like a key part of this is transparency into the process of where documents are in a current workflow and a current job and the status of those documents along the way. And yeah, under the hood, there's some queuing for jobs and workflows themselves, but we're also like keeping track of the state of all the documents in a central place for easy access. That's, without going into too much details, it would basically be per workflow. So it's, easy to bubble up, but also can scale to thousands or tens of thousands or more of workflows.
And then if there is a failure that happens for whatever reason, do I have to kind of sort of kickstart that from scratch again, or can I pick up sort of where things may have been left off?
Also, great question. So there's a certain amount of retry, back off and retry baked in, of course, like would be standard. And so if you requeue like any job, we can see the state of each document so that if it's processed already, it's basically a no-op. And so we just go back and, pick up where we left off.
Yeah, I guess you probably know which docs you've actually already processed, so you don't need to process them again, essentially. So you can skip over those.
Yeah, exactly. And like Matt was saying before as well, that one of the most expensive step, especially for images and PDFs, is that initial transform of going from that raw document to the structured JSON. So if you've already completed that step and you broke further down the line, well, in a retry, we just pick up further down the line. We can leverage the outputs that already exist and not, blow a bunch of compute reprocessing that document.
Right. That makes sense. As we start to wrap up, is there anything else you'd like to share?
Nothing else for me. Just really appreciate you having us on the podcast here. It was a really, really great time.
Great. Anything from you, Crag?
Thanks so much for having us on. I would maybe a quick plug for our Slack. We have an open Slack community. It's really easy to find if you just look for Unstructured GitHub project or unstructured.io website. And you were talking about like how can, the variety of document types. I mean, you really just get a sense for it from like the questions people are throwing out there. So it's like kind of fun to be there and observing anyway. But, we like welcome the conversation and the community. So, please, if you're interested, please join the Slack.
Yeah. I get people all the time, engineers I've worked with in the past or young engineers asking for, how do I get essentially my first sort of job in the AI, LLM world? And there's so many of these great open source projects in communities that you can kind of just like jump into. And that's really the easiest way is like, just get in there, get your hands dirty and start contributing.
Completely. I mean, I think the Unstructured open source library is a great example of that. There's, just look through the GitHub issues and some are not terribly complicated, right? And are very approachable for engineers that are early in their career. And so, absolutely a great place for engineers to get into the field.
Yeah, we try to mark some of those good first issues too for people trying to do that too. So if you're interested, check out our GitHub, look for a fun issue to work on, and we'd be happy to review it.
Awesome. Well, Crag and Mac, thanks so much for being here. I really enjoyed it.
Thank you.
Thanks.